let me write a little something, and then chapter 3. I don't know what's up with my focus lately here. Okay, hold on. There. Now we're talking. Don't know why it does that. Okay, so trigonometry in IAPR Oh, okay, hold on. I know why. There's a constant focus and there's a static focus. So now it's static. Now it should stay. In IPR, you learned about primary trigonometric ratios. We don't say trigonometric every time we say trig, okay? Primary trig ratios. Your teacher may have used SOHCAHTOA. Do you remember that? Yeah. Sine, cosine. That's right. And so sine, right, relates opposite and hypotenuse. Cosine relates adjacent and hypotenuse. Tangent relates opposite and adjacent. So there is some good news here. If you, for whatever reason, right, you were taking IPR and the shutdown happened, trig would have probably been covered right around spring break or after spring break. And if you had a hard time with it, this is maybe a time to redeem that, because you're not going to really need to know how to do these. In pre-cal you would, but now we're dealing with oblique triangles as well, and this only works with right triangles. So I'm going to give you something that always works. This only works with right triangles. Primary trig ratios only work with right triangles. What happens if you need to solve for sides in an oblique triangle? And just to make sure you know the difference, right? This is a right. Oblique would look something like this. It may be acute or it may be obtuse, right? It doesn't matter. This is also oblique. So anything that isn't right, it's called oblique, okay? So that, don't let that terminology throw you off. So I'm not going to review SOHCAHTOA. I'm not even going to go there, because the problem if I review SOHCAHTOA is that students think they can use it sometimes. So they just randomly Sometimes they get stuck and says like, hey, SOHCAHTOA, I remember that. I'll try that on this one. And it doesn't work, okay? It's not accurate. So you may have, I will maybe say, this is an acute, this is an obtuse, right? Because it has one angle that's bigger than 90, right? That makes a triangle obtuse right away. Oblique, right? We use the sine law or cosine law. There's no such thing as a tangent law. It's only sine law, cosine law. Those are the only two that that you need to know. And they're different. Each one of them is used in different cases, right? We're going to start with the sine law and then move over to cosine law. So sine law. If you are given a triangle like this, mind you, they won't always look like this, you know, where you have the base properly lined up with the horizontal, but this is a good start, right? So you have A, B, and C. We use capital letters for angles. I'm sure you know that. We use lowercase letters for the sides that are across them. So if this is capital A, conventionally, we call the side across it lowercase a. Across angle B, you'll have lowercase b. Across angle C, you'll have lowercase c there. And so what the sine law says, and if we have time, I will prove it to you, right? It's saying that if you were to take the sine of A, right, and divide it by the side that's across from it, you would get the exact same thing as taking sine of the another angle in that triangle, let's say it's B, dividing it by side C, and the same thing is sine of C. Oh, sorry. This should be a B here. Sine B, angle B over side B, and sine C over side C. These proportions, right, these ratios, they're all the same, okay? It doesn't matter what triangle you take, is it right or oblique, this will always be true. Or we can flip this as well. It's the same thing as, let's just write it so you know that both are true. Okay, they're both true. I would have one of these on my study sheet, right? The sine law and then the formulas, I would have that on my study sheet, making sure that, right, you make note of the fact that it's always a pair, right? They're always across each other. You can't go sine A over side B all of a sudden. Like it has to be in pairs. And I'll just make a note, like put a star here or two stars, right? Can be written both ways. So this is the sine law, right? This is what it states. And perhaps boxing in things make it stand out a bit more. Continuing, sine law works with right as well as oblique triangles. For sine law to work, comma, you need at least one pair, and I'll explain that to you in a bit. You need one pair this means that you need a known side and a known angle opposite to each other. For sine law to work, you need at least one pair, right? This means that you need a known side and a known angle, and that they have to be opposite each other for that to work. It works in these situations. So let's say you know any two consecutive angles, right? Let's say you were to know these two angles and the side length here. We would call this angle, angle, side, AAS, right? Another situation that might come in handy is when you know this angle, this side, and that angle. That would be called an angle, side, angle situation. So you have the side be connecting the two angles. So keep in mind, it could have been here, right? Angle, side, angle. It doesn't matter where on the triangle. If you see that pattern, it would work. And the last case would be you knowing two sides and one angle. So I read all of these counterclockwise, right? So angle, angle, side, angle, side, angle. And here would be side, side, angle. Don't don't stress over this too much, okay? Don't stress like, oh my goodness, I don't really get it. Like where do you start? Like what if I start here, right? This would be angle, side, angle, right? Like don't stress over it too much. I'm going to show you what you need to look out for more so than anything else. Always try to look for that pair, okay? So for example, if you know this and you know the side opposite to it, this would be considered our pair. Okay, let's skip this one for now. The middle one is a bit of a trickier situation because do you see a pair here at all? No, not yet. It's hidden. Do you see a pair here? Yeah, it's right there. So whenever you see a pair, you know without a doubt that that's going to be a sine law case. Because later on we're going to do cosine law, right? Then you're going to have to choose. Right now this is the only thing that you know, or that you will know in a bit, right? So you have a pair. Where's the pair here? When you have two angles, can you find the third one? Yeah. So there's a hidden pair. Right? Hidden pair. You find the top, right? Find third angle, right? Using, oh my, I'm going to run out of room here. Sum of triangles equal to 180. Okay, so this is like a side note. So it's not going to be, at first you're going to be like, wait a minute, I'm stuck, I can't do it. It's like, no, you can. It's just that extra step to find that third angle there, right? And then you would actually end up with a pair. Okay. So it's called like the hidden pair. Right? Okay. I want to make sure you have this down, so I'm kind of thinking of you at home. So take an extra minute to get that down. And again, I said it, the most important thing is to see the pair, because I'm going to be more focused on can you identify what to use as opposed to do you know what it's called, like the 3-letter abbreviation, right? Like if, by the way, if you started here and you went around, you would call a side angle, right? Like this S would be here. Not a big deal. The fact still remains that there are two angles that are consecutive, right? So, all right. Backside. I will make you write this down, right? Recall, right? Largest angle will be across longest side. Always. Okay, you need to remember that because later on it will come in handy. The largest angle in a triangle will always be across the longest side. So smallest angle will be across shortest side. And that goes without saying that the one in between is going to have the side that is in between the longest and the shortest, right? So just keep that in mind. I think that's it for this. I'm just gonna do that. And now we're gonna solve. Now we're gonna do some work here. Applying the sine law. Okay. Solve for side B. Okay. So you can tell that, right? If you have two angles and we have a side given to us. So this would probably be angle, angle, side, right? Angle, angle, side if you wanted to name it. Or side, angle, angle, it doesn't matter. Okay. What you need to remember here is that you will have your pair. Okay? You have a pair. Pair, therefore, sine law, right? So that is important. We know we're going to use sine law, right? Additionally, if you wanted to solve for side B is right here, right? Which is unknown to us. In order for you to be able to find that side, you would need the angle across from it. Because remember, when you write down your formula, it's always the angle across from it that you need to find the side. Like here, right here, you have two unknowns. But you can easily find angle B by using the sum of 180 property, right? Need to determine angle B in order to find side B. So angle B is going to be 180 minus 62 minus 38. Angle B is going to be 80 degrees. So that'd be your first step. Start with the pair. So now we're going to say, okay, sine of 62 degrees. Remember that the angle always couples with sine. You can never just put the angle down when you're doing a sine law question. You can't just say 62. I see that sometimes. Angle is always together with sine, okay? Divided by the side, which is 4.5. I tend to always put the angle on top, the side length at the bottom. That's how I do these. You could flip it the other way, just be consistent. And over here, I'm going to go sine of 80 over side B, because remember, this is now 80 and these two will go together in your setup. But make sure angles are across each other and side lengths are across each other. You can't just flip-flop, okay? And here's my trick. I'm going to show you the algebraic way of doing this, and then I'll give you my shortcut, okay? So you probably learned how to cross multiply and divide, right? So you got to multiply across like that. So b times this gives you b times sine of 62. 4.5 times sine of 80 is 4.5 times sine of 80, and I'm mixing it all up, right? I'm doing dot here, I'm doing brackets here, it's the same thing. Don't let that throw you off. At this point, we want b isolated, so we're going to divide both sides by sine of 62. And remember, sine of 62 is just a number. Your calculator will spit out a number if you type that in. So don't be scared of that, right? So here we get to cancel out these two because it's like b times 2 divided by 2, right? It's like nothing happened. And on this side, you do all the math happens on the right side. So b is equal to, one thing that I'm going to warn you before we even get started, look at the top of your screen. So grab your calculators, right? It has to say degree right here. If it says radians or gradients, you're going to get the wrong answer, okay? So if that is you, for whatever reason, you press mode and the third line down, right? Just switch it over to degrees. Hit enter, right? Highlight degree, and then it's there. And you should also have like auto, real, degree, float, like all these other things should also be the same for you to get the same answer as we are, okay? Okay, clear screen, 4.5 times sine of 80. I always do that first, and then I go divide by sine of 62. So that gives you 5 point, and this is our final answer, so we'll round it to 2 decimals. And we are in meters. So we've now solved for side B. I'm just going to add here, solve for side C. This is just an aside here. I'm going to cut this off on that side, right? How would you solve for side C? Oh, sorry. I meant A. My bad. Can you change that to A? We already know what C is. It's 4.5. Side A is over here. Start with the same pair that you were given at the beginning, okay? Do the same thing. And now, so this is known. You want side A, which is over here. You need to use the angle that's across from it in your setup. And so this is A. All right? So angle across from A goes here, and this is our unknown. I'm using the same pair that I started with here when I was solving for side B. And here's the shortcut that I'm going to give you, okay? Cross multiply diagonally like this. Always multiply these two and then divide by what's left over. And that always gives you the answer. So you can just show me that work. 4.5 times sine of 38 divided by sine of 62. And believe me, it's the same thing as what we did on this side. Right? It's the same process, it's just a shortcut. And let's go ahead and solve it. 4.5 times sine of 38 Divide by sine of 62. You get 3.14. And let's just pause for a moment and see if that makes sense. Right now, 38 is the smallest angle of them all, right? We've got 38, 62, and 80. Technically, 38 should have the shortest side across from it. And let's check. It's 314, which makes that true, right? 314 is across the smallest angle, and 80, which is the largest angle, has the longest side across from it, which is 5.02. So it all checks out. Don't just blindly trust your answers. Always check for, right, for consistency. Okay. We're going to do a couple more. Okay, so question B here. Solve for side A. And I'm going to give you a question here. And I'm just using ABCs for now, but the letters really will change. Right. So I do looking back the question we just did, like I probably should have done A first to not have to worry about finding that third angle and then done this. But really, you know, it doesn't really matter as long as you know what you're doing and that you can't have more than one unknown, right? If you have two unknowns, you can't solve for that particular pair, right? If this is unknown and this is unknown, you can't do it. Okay. So look at that from that perspective. Okay, what do we call this? Angle side angle. That's the type of triangle that we're presented with. This has a hidden pair. Okay. So I would almost say if you have two out of the three, just find C right away or find that third angle right away. So it's just get it done and over with. And you get that it's 75 degrees. Right, so actually you found that this is 7. I'm going to use a different color so you can see that. Anybody recognize what type of triangle that is? Isosceles, right? Right? Because if these two side angles are the same, right, then this side will be the same thing as the one across. In fact, you've now found side B just like that. You know, you know that this is 14.5 also, but that's not what they're asking for. So I'm not gonna talk about that. I should probably do this with a different color so you don't think that wasn't given to you from the get-go. Triangle ABC is isosceles, right? Just a note. It's good to be aware of a lot of things, right? It doesn't look like an isosceles because I didn't draw it to scale, but right, it's still the fact remains. Okay, so let's see. I have a pair now. Now I have a pair. Okay, I'm going to start with that. I'm going to go sine of 75 degrees over 14.5 is equal to, I want side A, which is right here. So I need to use the angle that's across from it. Okay, so A is there. So to find A, I cross multiply, right? If A had been up here for whatever reason, like let's say you set it up differently, A is up here, you have to cross multiply up, right? So keep that in mind, 14.5 times sine of 30 divided by sine of 75. So here, I guess you have to be careful in using your calculator to not make a mistake, right? .51 centimeters. And I could ask you now, like, I could actually ask you an extension, like, what's the perimeter of this triangle? And I hope, like, I need you to know that the perimeter would just be adding all of them up, right? So you just have to do that extra step to do that. Okay, so now we've done finding sides, but what about finding angles, right? So we've done a couple of these, so now we're going to find angles. I have a note on I'm just going to add that here because you might look at this weeks, months from now, right? So I'm just going to angle across side A, right? Angle A is across side A, right? So that's very important because if you had picked another angle, you're not finding the correct side, okay? So we did sides, now we're going to do angles. A little different, but the same setup, okay? Just at the end, it's a little different. Question C, triangle ABC has A equals 6 centimeters, C is equal to 3 centimeters, and angle A is equal to 34 degrees. Determine angle C. Okay. Oops. Sorry. All right, so no diagram provided. Okay. You also have to be good at that. Okay. What I would say is don't draw it to scale. Just make a triangle, right? And don't make it right. Don't make it a right triangle because that'll throw you off. Okay. Most likely not going to be one. And then you just go ABC. It doesn't matter if you go clockwise, counterclockwise. It's the same. It's going to give you the same answer. And we know that side A is 6 centimeters. Side C is across, that's 3 centimeters. And we know that this angle is 34 degrees here. So what kind of case is this? Right? And technically this would be the SSA scenario, right? Side, side, and then angle. Or angle, side, side, which I don't like to use because it spells something that wouldn't be appropriate, right? But if it helps you, right, there it is. So SSA, plus I'm on camera and I'm recording this, so I have to be double careful. Okay, anyways, we see the pair. Boom, I know it's sine law. Mr. Dirksen told me so, right? So we start the same way. Sine of 34, you start with your pair, right? Over 6 is equal to, you're trying to find angle C, correct? You don't know what it is. And you don't copy this down right now, but I see a lot of this. Just wait a little bit, don't copy yet, right? I see a lot of students doing this. Because, hey, I'm trying to find C, right? Like, what's the big deal? You're finding angle C. Remember, angle needs to be together with sine, right? So you can't do that. Don't do that, okay? It has to be sine of C, like that. Because you're trying to find angle C. You're going to treat it the same way as before. This is your unknown, right? So you're going to cross multiply up like that. You're going to go 3 times that. It's always diagonally that you multiply. And you're going to divide by what's left over. So sine of C is going to be 3 times sine of 34 degrees divided by 6. One more line, sine C is equal to, let's figure out what this is. And it has to be less than 1, okay? If it's 1 something, you're going to be, if you don't get 0 point something, you're going to get an error. Don't raise your hand on a test and say, Mr. Dirksen, I'm getting an error. You're doing something wrong. Okay, that's basically what that is. Okay, you set it up wrong. You cross multiply something happened and it's not right. 3 times sine of 34 divided by 6. Make sure you close that bracket. Okay, a lot of students don't bother closing the bracket. And you know what? I'm never sure if that does make a difference, but let's say you forget. This is what you're supposed to get. And it's different, see? It's different. So don't like close that bracket or else it will, I think what's happening here, it's dividing 34 by 6 first and then taking the sign if you leave it like that. So careful, okay? So it's this one. So you write down 2.79 and just go dot, 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 right? Just write down a couple decimals. And then angle C, anybody remember what happens to if you want to find the angle? You use the inverse, sine inverse. So notice that C, all of a sudden you drop the sign, you just go angle C. Therefore, on the other side, it has to appear as an inverse because you're basically taking the inverse of both sides. You know how squared, if something is squared, you square root it to get rid of it? Same thing here. No, we want to use all decimals. Yeah, yeah, all decimals. 0.279, and I just go dot, 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 right? So watch how I'm going to do this on my calculator, okay? Let's see if I can delete that line. Yeah, I can. Okay. So you're going to go second. You see that arrow up already, right? Second, and then you press sine. So second, and then go press sine, then you see the inverse. And then because we have these awesome calculators, you can just go up and just paste it in there. Close the bracket. And it's 16.24 degrees. Always 2 decimals, your final answer, right? Final answers only. So that's what you're getting. And think about it this way. If 6 has 34 across from it, right? then a shorter side should have a smaller angle across from it, which makes sense. But it's not quite half, right? So keep that in mind. Some students say, oh, it's just going to be half, not necessarily. So there is one where you solve for the angle. Could you now solve for B? You can now solve for angle B as well, right? Angle B would be 180 minus 34 minus 16.24. And yes, I used 2 decimals. So angle B is 129.76 degrees. Oh, there's an obtuse angle. Not a big deal, right? Oops, sorry. I'm just checking something. Hold on. Yes, okay, that works. Yeah. Okay, so solving, if I ever tell you to solve a triangle, it means to solve for all 3 sides. And all, by the way, drawn, the way I drew it, this doesn't make sense at all, right? But remember, I didn't draw it to scale. I didn't sketch it to scale, so don't worry about that, right? But we could now find side B as well, right? Because we do have a pair, we do have this angle, so if we wanted to, we could find a side B and get that done. Okay, one more. So this would be D, right? Okay. Length of Q. So you're looking, where is Q? It's right here. So this is my unknown. You should notice right off the bat that Q is unknown as well as the angle across from it. So you're going to have some extra work ahead of you. But this is what should also stick out, that you have a pair. Right? So we use sine law. And basically what you're going to ask yourself, what can I find? Is there something that I can find? Well, I'm going to start with my pair, right? Because that's a given. You're going to have to start with that. And on the other side, you look at what else is given to me. I have this side here, right? The side length is given. This is an SSA, by the way. This side length is given to you, so I can put the 9 here and try to find angle R first. which in turn is going to allow me to find angle Q, which in turn is going to allow me to find side Q. So this is a two-step question, right? So sometimes it's just better to just try to solve for everything, and maybe along the way you might find what you're actually supposed to find, right? Like if all else fails, just do that, right? So sine R is what we're going to solve for. Okay. Maybe what I will do here is I will add a note here. Can't solve for side Q as is, right? Find angle R first, since you know the side across from it. Okay, so you have to be investigating, right? Like, what can I do, right? And okay, so you start with your pair, you set up on the other side. One of them needs to be known, and they're always across each other. That's what you need to remember. I'm trying to find angle. That's my unknown. I'm going to multiply here. So sine of R is 9 times sine of 77 divided by, what happened there? I almost crossed off sine of 77 there. 9 times sine divided by 12.7. Sine of R is going to be 0 point something, right? Mr. Dirksen told me I'm expecting a 0 point something there. Let's see if that works out. And I do. Right, and it just keeps going. Angle R is sine inverse of 0.69, right? Dot, dot, dot. And practice will be critical here. Okay, you practice this, you will become better at it, guaranteed. Okay, then I find angle Q, (59.33 degrees). Is something off, or oh no, I'm good. My original example had 9.1 instead of 9 inches, but that's okay. We won't change it now. We'll just keep going with this. Okay. Now that you know Q, you start again with the pair, right? I would not recommend you picking a different pair, because technically you have another pair. Once you found R, you have another pair here. But what if you made a mistake in finding R? It's going to transfer over. I would say stick with that one. So 12.7 is equal to, we're gonna use sine of 59.33 over Q. Then we're gonna find Q, and 12.7 times sine of 59.33 over sine of 77. No inverse here because you're not finding an angle. Okay, you're finding a side length. Keep those separate. Okay. I get 11.21 inches. Make sure you don't forget your units. And there you have it. So this one would be a 3-mark question, most likely. With that. So, homework. I draw from the textbook here. Just gonna check if I can give you all of the ones I've written down. I'm gonna go, yeah. Homework. Page 125. You can go 1 to 6. And 6 has triangles without a diagram. And yeah, just practice those two. And if it ever says solve the triangle, that means solve for everything. All angles, all sides. Okay? That is all for today. Your quizzes, I'm still working on them. It takes a lot longer.